Yes, welcome to this. Yes, this is DC Economics. So I want to take you on how to fill the regression equation. So for example, a market manager of a large supermarket chain has the business objectives of using the shelf space most efficiently. Toward that goal, she would like to use the shelf space to predict the sales for pet food, and data is collected from a random sample of 12 equal-sized stores with the following results. So from this data here, we have the store that we have 1, 2 up to 12, and we have the shelf space that is equal to 5 up to 20, and we have weekly sales that's represented by Y in Tanzania shillings is equal to we have 160 up to 310. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 5, 5, 5, 5, 10, 10, 10, 15, 15, 20 up to 20. So here we have 160, 220, 140, 190, 240, 260, 230, 270, 280, 260, 290, and 330, as you can observe. So starting from the 160 up to 310 represent out the weekly sales in Tanzania shillings. That is represented by Y. So we are required to construct a scatter plot to determine the field regression equation, to interpret the meaning of the slope beta 1 in the problem, to predict the sales for pet food when we are provided with 8 feet of the shelf space for pet food as observed. So let's go quickly to solution. As observed, we have almost 1 to 4 we require to solve out. So solution now, we construct a scatter plot. Now we construct by looking the highest and the lowest. We have the shelf space X feet that's represented by X. We have the weekly sales that presented by Y. So we draw our graph like this. So the shelf space is presented by what is by the shelf space feet that is presented by X, and the weekly sales presented by Y. So after that we consider to look the highest and the lowest value of the numbers between the weekly sales and shelf space, so as you can set out our scale that will be very appropriate in sketching out the graph, the scatter plot. So the highest value you have is 310 inside of side, and the lowest value is 140. So from that case we can draw the Y and X axis. So we have 40, we have 80, we have 120, we have 160 on the Y axis up to 240, we have 280. This is the Y axis. But also we have the what is known as we have also, apart from the Y axis that we have 320, we have also the X axis, that is we have 3, 6, we have 9, we have 12, we have 15, we have 18, and we have 21. So when you sketch out our data now, you observe to sketch out 3, we take out 3 to 40, that we sketch out our graph over there. So we have X which is equal to 5, and Y which is equal to 160. So we sketch out our graph from the position of X which is equal to 5 to Y axis which is equal to 160. Also, we have another point when x is equal to 5 and y is equal to 20. So we come to the position of 5 to the y-axis where there is 220. We set out our point at that point over there. When x is equal to 5 and y which is equal to 140, so it will take the position from the x-axis, which is x is equal to 5, to y which is equal to 140 at that position over there. Again, we consider another point. Suppose we have x which is equal to, suppose we have x is equal to 10 and y which is equal to 190. This will appear at that point of x-axis where there is a 10, at that point of y-axis where there is 190. So it will be at the middle of this point over here to that point over there. So it will stay at that point of the mid between 9 and 12, and at between 200 and 160 at that point over there. But also we have x which is equal to 10 and y which is equal to 240. This will appear at that point of 240 over there at that side. And suppose also we have x which is equal to 10 and y which is equal to 260. This will, it will take at the position of the top below the points of y is equal to 240 and 190. But also let's consider another point. Suppose our x which is equal to 15 and y which is equal to 230. Our point will go to the x-axis. We'll be drawing from the x-axis which is equal to 15 to 230 at this point over here. But also suppose we have x which is equal to 15, our y is equal to 270. Our point will be positioned at that point there. X which is equal to 15 and y which is equal to 280. Our points will appear at the x-axis of 15 here, at the point of the upper button on the 280. Also, let's consider that our x is equal to 20 and our y is equal to 260. So when x is equal to 20 and y is equal to 260, our point will appear on the x-axis as you observe. Here we have 15, here we have 18, and here we have exactly 20. We have 18 and we have 20. So we draw up to 21 point over there. Then we sketch out our 20 or this point to this point over here. So also x is equal to 20 and y is equal to 290. So our point will exist at the bottom part below the x which is equal to 20 and y is equal to 260 as you observe. So exactly our scatter plots are trying to show that they are positively related between y and x-axis. As our scatter plots are organized, show that there is a positive relationship between y and x, as our scatter plots are moving from the left to the upper sides of the graph. So it shows exactly on the feature that there is a positive relationship between y and x. Now after taking that, let's go to B. Now you're required to fill out the regression line. You're required to fill out the regression equation. Now, how do we fill the regression equation? Now, solution. We take out our y estimated is equal to beta naught estimated plus beta 1 x1. So that is beta 1 estimated x1. So our beta 1 is equal to summation of xy minus summation of y over summation of x. Divided by the number of observations summation of x2 minus summation of x raised power of 2. Now let's consider to know out the beta naught. So in order to obtain the beta naught is where we take out beta naught which is equal to y summation of y minus beta 1 times sample mean of x. So we take the sample mean of y minus beta 1 sample mean of x as observed. So this is the formula of calculating the beta 1 and beta naught. Or sometimes you may apply another formula, that is summation of y is equal to NBO. That is number observation times beta naught estimated plus beta 1 times summation of x1. Summation of x1 y is equal to beta naught estimated summation of x1 plus beta 1 summation of x1 as you observe. Now we solve out. This means that we take out a value, we solve out summation of x1, summation of y beta naught plus times x1 times beta 1 summation of x1 square. So for our case, we will apply the first formula. So we consider now to apply the first formula as you observe. That is beta 1 is equal to number of observations summation of xy, summation of xy minus summation of y times summation of x over number of observations summation of x square minus summation of x raised to the power of 2. So we take out our beta naught, which is equal to sample mean of y minus beta 1 sample mean of x. Now for that case, we plug in our data. We consider what is known as y bar on the upper side is the sample mean of y, and x, that is the sample mean of x. So for that case, we need to understand that when we take out summation of y is equal to summation of y over number of observation, and summation of x, sample mean of x, summation of x over number of observation. So when we plug in to solve out the sample mean of y and x, this will give out, this is like we say it will be, we consider to plug in to check out from our data formula, and this will appear in the forms that when we draw out our table. Now we sketch out our table. So we'll present out the x and y, whereby our x represent out what is known as shelf space, and y represent the weekly sales. So we sketch out a graph and add and try to find some data that will be appropriate in plug into our formula. So there we have the store, we have what is known as a shelf space, but also that's presented by x, and we have what is known as weekly sale, that's presented by y. So let you plug in. So we take out, we have what is our weekly sale, that is 55 up to 20, and we have the weekly sale that is equal to 160 to 20 up to 310. So you have the store, summation of the, we have what is known as the shelf space, as you can observe, that's presented by x, and summation of, and we have y, that's represented of the weekly sale. So we consider to find out the summation of x and summation of y. We take out the summation of x together with summation of y. So the summation of x, this will be equals to 165 as you observe, and the summation of y will be equals to 400 and 180. So we take out the summation of x, that is equal to 160 when you time to plug in. So here we have what is known as a summation of x, which is equal to 165, and we have also the summation of y, which is equal to 2850. So we take out xy by times out shelf space and weekly sale, that is 5 times 160 is equal to 800, 5 times 220 is equal to 1140. When we take out 10 times 240 is equal to 24,000. The same applies here, it will be 3900. Here it will be 3,450. Here will be 4,050. 20 times 280, that is 5,600. 20 times 260, that is 5,300. And 20 times 290, that is equal to that will give out 5,800. 20 times 310, that is 6,200. So we find out for x square, then before that we sum out the xy, that the summation of xy will give out 4,180. It will be 41,800 as you observe. So it will be 41,800. We times out summation of x square. We take out x raised to the power of square, that will give out 25, 25, 100, 100, until to 400, 400, 400 again. So then we find out the summation. The summation of x square would be equals to 2,625. So the same applies, we find out for y square. We take out y, we raise power of 12. 160 when we raise power of square, it give you 25,600. It will give you 48,400. It will give you 9,600 as you observe. It will give you 36,800 as you observe. 57 is 600 as you observe. 67 600. Here it will be that will obtain out 57. It will give you 72 and 900 as you observe. This will give you 78 and 400. And here you'll obtain 78 and 400 as you see. This will give you out 67 and 600. Then there will obtain 84 and 100. And there will obtain 96 and 100. So we may find out the summation of y square. That will give out 7006, which will give you 76900. So that is the summation of y square. Now, after finding that the number of observations are well known, the summation of xy is actually observed. The number of observation is equal to 12. And what you need now, you need to plug this data now to our formula, so as you can find the beta 1 and beta 1 together with beta naught. Now we go straight and find out beta 1 is equal to number of observation summation of xy minus summation of y summation of x divided by number of observation summation of x square minus summation of x raised to the power of 2. So we plug in the beta naught is equal to sample mean of y minus beta 1 times sample mean of x. So when we plug into our formula now, you can find now summation of x, which is equal to 165. We understand the summation of x1, summation of y is equal to 2850, summation of xy is equal to 41800, summation of x square is equal to 2625, summation of y square is equal to 76900. Number of observation is equal to 12. Now when we plug into our beta 1, it will be number of observation times summation of xy minus summation of y times summation of x divided by number of observation summation of x square minus summation of x raised to the power of 2 will give out now 12 times 41800 minus 2850 bracket times 165 bracket divided by number of observation 12 times 2625, then minus 165 raised to the power of 2. So this will give out now beta 1 is equal to this will be equals to 50, and the upper side you will obtain 51600 minus 470,250 divided by 331,500 minus 27,225. You will obtain now 31,350 divided by 42,275. So we obtain beta 1 is equal to 7.33 as you observe. So that will be our beta 1. We sometimes call the slope coefficients. So that will be equal to 7.33. Actually, that is how we do for the beta 1, and it is easy manner as you observe. So actually this is a positive answer. So we actually let's go now to find on beta naught. Now from beta naught we have is equal to sample mean of y minus beta 1 sample mean of x. So since now our beta 1 is 7.33, now we plug into our data set. So we find out the sample mean of y is equal to summation of y over number of observation. Now the y sample mean is obtained by taking out the total value of summation of y, that is 2,850, and summation of x is equal to we actually obtain 165. So when you plug in and divide by the number of observation, this will give out now y is equal to 2850 divided by 12. The answer will be sample mean is equal to, when divide 2850 over 12, we'll obtain 237.5. What about now x? We take out x is equal to, now it will be equals to 165 divided by 12. So when you take out 165 divided by 12, this will give you the answer that is equal to 13.75. So now let's plug in now this data to our formula. Now beta naught will be equal to sample mean of y, that is equal to with 237.5 minus 7.33 times 13.75. So the answer now for beta naught will be equals to, when you take 7.33 times 13.75 and take 23.75, you minus the answer. The answer will be equals to 2. This will give out when you try to times out, the answer now will be equals to beta naught is equal to 13.75. So we find out the beta naught is equal to 23 is equal to that will give out beta naught that is approximately to the true value as we obtained on the previous case. So it will be equals to 136.67125 as you observe. So that is equal to beta naught. We sometimes call the constant in the regression model. So actual our beta naught is positive answer, that is equal to 136.67125, and actually this is a constant value that it do not cause any change on a dependent or independent variable, as it's actually resulted due to the x1 in the regression model to be equals to 0. Now let's go to part C. So required to interpret the mean of the slope of beta 1. We need to interpret now required to interpret the slope of beta 1, that is now will be equals to y estimated is equal to beta naught plus beta 1 x1. So when you take out 13.67 and you plug in the beta 1, we give you 7.33, that is x1 as you observe. So when we try to interpret, we have this is called the beta 1, that is a slope coefficient, and beta naught, which is 13.67, this is a beta naught, that is a constant. Now for that case, the slope beta 1 7.33 implies that when x1 or the shelf space increases by 1 unit, it will lead now to a decrease of weak resale by the same unit of 13.75. So the slope beta 1 actually implies that the coefficient of x1, that it implies that when x or the shelf space increases by 1 unit, it will lead also to a decrease of weak resale by the same amount of unit. By the same amount of unit as you observe. So the same amount of unit, that is 13.75. That is equal to 13.75. So actual we interpret in this case here because our slope coefficient is positive. So there is what is called that x1 is trying to increasing by 1 unit. So as a result also the predictable variable, that is why, or we call the regressant, is increasing with the same unit of the same unit as it occurred on x1. So for that case, actually that is the way we have to tackle the question in an easy and well understandable way. So bear in mind that the beta naught, the slope coefficient is positive, so it could be negative. We could interpret in a different manner, and since it's a positive, now the increase of 1 unit causes the same increase. Now you're required now to solve a predictable variable. You're required to predict for the values of y, how y will be if the shelf space give out 8 feet of food space. So required to predict for food stores with 8 feet shelf space per food. So how do we predict for the sale for the plate of food with the 8 feet of the shelf space per food? We need to generate from our regression model. So we plug in our x, that is an independent variable that causes the changes toward the dependent variable. So solution now, we take out now from our y is equal to y estimated is equal to beta naught plus beta 1 estimated times x1. So let you plug y estimated, that will give you our beta naught is 136.667 plus beta 1, that is equal to, we actually already solved beta 1, that is 7.33 x1. So let you plug the value for x1, that is 8 feet. So when you take out plus 7.33, we plug in our x1, that is 8 feet. So the y, or predictable variable for y, will give out what is, when you times out 136.67 plus 7.3 times 8 will give you actual 59.5.334. That will be the required value, that is 195. Thank you, and I welcome you to DC Economics. Don't forget to subscribe my channel, and bye bye.